So how on earth does a company like DoorDash predict the future? I mean, we're talking thousands of unique markets, all at once. Every single choice they make, from operations to finance, it all hinges on getting this right. But forecasting at that scale, well, it forces you into what feels like an impossible choice. And today, we're going to break down exactly how they cracked it.
Right, so how do they pull this off? You got to remember, this isn't just one big forecast for, say, the whole US. No. We're talking about thousands of forecasts all happening at the same time for every little submarket. And each one has its own vibe, right? Its own holidays, its own weather, you name it. The scale of this problem is, well, it's just mind-boggling.
And this right here, this is the classic headache in forecasting. It's this great trade-off. See, on one hand, you want your predictions to be perfectly accurate. But on the other hand, you need those predictions now, and you can't break the bank to get them. In data science, this is like the golden rule. You can have it accurate, fast, or cheap. Pick two. Getting all three? That's the holy grail. You almost always have to give something up.
All right, Section 1, Forecasting's Impossible Trade-Off. Let's dig into this, because for the folks at DoorDash, this wasn't just some textbook problem. It was a very real, very painful bottleneck that was slowing everything down. So the old way of doing things is a method called grid search. And really, you can just think of it as a brute force attack. You literally throw thousands, and I mean thousands, of different models and data combinations at the wall to see what sticks. You test every single one and then pick the best performer. Now, don't get me wrong, this can be super accurate, but for a company the size of DoorDash, it's a total non-starter. It's incredibly slow and expensive. We're talking hours of runtime and big bucks in computing cost for just one forecast.
Okay, Section 2, the limits of one perfect model. So, banging their heads against the wall with this old method led them to a really important insight. What if the problem wasn't how they were searching, but what they were searching for? What if this whole idea of a single perfect model was just wrong?
Yeah, it turns out any single model, no matter how good it seems, has some serious flaws. First, they all make these kind of unrealistic assumptions. The real world is messy, right? A model might only be built to see one simple weekly pattern, but in reality, there are tons of complex patterns all overlapping. Second, they tend to be specialists. A model might be an absolute rock star at predicting what a snowstorm will do to orders, but then it's completely useless for predicting a regular old Tuesday. And third, they can just be unstable. They can spit out these totally wild, extreme forecasts that just make you scratch your head.
Which brings us to Section 3, the power of a team. Okay, so if a single hero model isn't going to cut it, what do you do? Well, this is where they had their big aha moment. They completely flipped the script. Instead of looking for one genius, what if they built a whole team of experts?
And this idea has a name. It's called Ensemble Learning. The concept is actually pretty straightforward, but really powerful. You just take a bunch of different models, these are your base learners, and you combine all of their predictions. The final result? A single forecast that's way more accurate and way more stable than what any of those individual models could have produced on their own.
I love this quote because it just nails the change in thinking. Instead of searching for one genius model, they built a team of specialists and a manager to lead them. It's perfect, right? They're not looking for a superhero anymore. They're building a committee of experts, and then they're putting a smart manager in charge to listen to everyone and make the final decision.
So let's get into Section 4, building the elite model. Because that's exactly what they did. They built a system they call Elite, which is basically this team of models idea brought to life. So let's pop the hood and see how this thing actually works.
It all boils down to three main steps. Step 1, you pick your team. You choose a whole bunch of different, diverse forecasting models. Step 2, you let them all do their thing. Each model generates its own prediction. And then, Step 3, the manager steps in. You take all those individual forecasts and feed them into a final top-layer model. This manager model is smart. It learns who's good at what, weighs their opinions, and combines everything into one final, much-improved prediction.
Now here's the magic that makes this all possible at scale. The whole process is supercharged by running it on a distributed system called Ray. They use this really clever technique called nested parallelization, which basically lets them train all the models for all the markets at the exact same time. It's how they get around that massive speed bottleneck of the old grid search method. It's just incredibly efficient.
Okay, time for Section 5, putting elite to the test. The theory sounds great, right? A team of models beats a single genius? But did it actually work? This is the moment of truth. Let's look at the results.
And the results were,
Well, they were stunning. First up, speed. A 78% reduction in execution time. Think about that. Tasks that used to take hours to run were suddenly done in just a few minutes. That is a massive difference.
And then there's the cost. This one is just wild. A 95% reduction in computation cost. They were basically spending pennies on the dollar compared to before. Just a huge, huge efficiency gain.
But here's the real kicker. This is how they solved that impossible trade-off. Elite wasn't just faster and cheaper, it was also 12% more accurate. They didn't have to choose. They got all three. Faster, cheaper, and better. That's the dream, right there.
And here are those numbers all laid out. When you look at Elite versus the old grid search for their weekly forecasts, I mean, it's not even a contest. Execution time, cost, accuracy, it's a clean sweep. A total game changer.
And you know, the impact went even deeper than just making the old stuff better. The speed and cost savings of Elite actually unlocked brand new projects that they couldn't even think about doing before, like forecasting delivery times at a hyper-granular level, a task that was just flat out impossible with the old system. It would have taken forever and cost a fortune.
So, we're at our final section, smarter, not harder forecasting. What's the big lesson here? For me, it's about a total shift in mindset. It's about working smarter, not just throwing more computing power at a problem.
Now, to be clear, this isn't a silver bullet for absolutely everything. If you're trying to predict some super rare, once-in-a-lifetime event, a single, highly specialized model might still have the edge. But for the 99% of everyday, common scenarios, the team approach, the ensemble model, is just far more accurate and way more reliable.
And this is the really crucial point. This isn't just about forecasting orders for DoorDash. What they've built is a flexible framework. This whole team of models idea can be used for pretty much any big machine learning problem where you're stuck trying to find the single best model out of a ton of options.
Which kind of leaves us with one last big question to think about. This whole strategy, building a team of specialists instead of hunting for a lone genius, was a massive success here. So it makes you wonder, where else could this idea work? What other huge, complex problems could we solve by building a team of AI experts instead of searching for just one?